Hello viewers, I am Kausalya. Today we are going to solve problems related with transients. The problem is, in the figure V of t is equal to 10 volt, find I2 of t. Assume all the initial conditions to be 0, use Laplace transformation technique. So here the value of V of t is given and the value of the elements are given. Here we are expected to find the value of I2 of t. Right. So here we have to use Laplace transformation. So the first step is I am writing all the parameters in S domain. Right. That is I have taken Laplace transformation for all the elements which are present here. So 10 becomes 10 by S, zero point 0.1 becomes 0 0.1 S. For resistors, they always remain the same. And for the capacitors, you see, it is 1 divided by 0.5 S. That is 1 divided by 0.5 is 2, therefore 2 by S. And here I becomes I of S and I2 becomes I2 of S. Right, so this is your first step. Now we are going to apply our current division rule. Right. So what is the current division rule? Current division rule is nothing but total current into opposite resistance divided by total resistance. So here we are finding I2 of S. Right. So the total current here is I of S. Right. This I of S gets divided into 2. So total current is I of S into opposite resistance. So here the opposite resistance is, we need to calculate the current which flows through this. So the resistor which is opposite to this element, not only resistor, the element which is opposite to this resistor is 2 by S. Therefore, total current into opposite resistance divided by total resistance. Therefore, that becomes 2 plus 2 by S here. Right. So here the next step is we are taking LCM and we are simplifying the expression. So once you simplify, we are getting the answer as I2 of S is I of S divided by S plus 1. So name this as equation number 1 here. Right. Now the next step is we are going to calculate the impedance value. So when you calculate impedance, you see, just look at this diagram. That is the total impedance present in this circuit is. Right. Since we are having a capacitor and inductor, here we are using the name impedance, or else we can say it as resistance. Right. So here these two are connected in parallel and these two elements are connected in series. Right. So when you solve, these two things become single one and these two become a single one, and that combination comes in series. Right. So you see, since these two are in series, the impedance I am writing it as 1 plus 0.1 S. Plus, again these two are in parallel. Therefore, here we are writing it as 2 into 2 by S divided by 2 plus 2 by S. And these two combinations are in series. That is the reason why here we are putting a plus sign. Right. Then again, as usual, we have to solve. We have to take LCM. Once everything is done, you see, this is our final expression. 0.1 S square plus 1.1 S plus 3 by S plus 1. Right. So, we know the value of total impedance of the circuit. So, the next step is we are going to calculate the total current. So, here the total current is I of S. So, I of S is given by V of S by Z of S. So, here just substitute the values. What is the value of V of S? It is 10 by S. And impedance is this one. So, divided by Z of S. So, when you substitute the value of Z of S here, it will appear as a reciprocal. Right. That's the thing happen here. So, S plus 1 divided by 0.1 S square plus 1.1 S plus 3. Right. Name this as your equation number 2. Right. So, what is the expression for I2 of S? You see, when you again look back, this is your expression for I2 of S. Right. Now, we have calculated the value of I of S. So, just substitute the value of I of S in this equation. So, once you substitute, you see, right, we have just substituted the value of I of S. So, after substituting and simplifying, again how to simplify? The same thing. Here, I am taking this 0.1 outside. When you take this 0.1 outside, this is how your expression gets modified. That is 10 by 0.1 becomes 100 here. So, this is your expression. Now, again you see, here we are having a quadratic equation. So, we have to write it as two independent factors. Right. So, you have to find two numbers in such a way that when you multiply, it should give the answer of 30, and when you add, it should give 11. So, here we are going with 5 and 6. Right. So, this equation is again simplified like this, right? So this is your I2 of S. So again here we have to apply partial fractions, right? Here we are having three terms, so here we are having three constants. So the next step is we have to take LCM. Once LCM is done, we have to find the values of these constants K1, K2 and K3. So first we are substituting the value of S as 0. Once S is substituted as 0, K2 and K3 become 0 because here we are having S, right? So we can easily find the value of K1. Therefore, the value of K1 is calculated as 10 by 3. And the next thing is we are substituting S equal to minus 6 and we are calculating K3. And for the next thing we are substituting S equal to minus 5 and here we are calculating the K2. Right. So after finding the values of K1, K2, K3, substitute in the expression for I2 of S. So this is your I2 of S. Right. Now we need I2 of T. Therefore, here we are applying our inverse Laplace transformation. So, once you apply inverse Laplace transformation, you see 1 by s becomes 1 and 1 by s plus 5 becomes e to the power minus, this is 5, right? Not 50, okay? E to the power minus 5t and here 1 by s plus 6 is e to the power minus 60. So, finally, this is our expression for I2 of t. Right, this problem gets over here. We will proceed with the next one. The problem is, in the circuit shown in figure, determine the current equations for I1 and I2 when the switch is closed at t equal to 0. So here again we need to find the values of I1 and I2. Right. So when you look at this diagram is bit different. Right. So when you look carefully, you see I1 flows in this way, right? I1 flows in this way and I2 flows in this way. Can you get? I1 flows through this 100 volt, 20 ohm and 15 ohm. Okay, the circuit gets closed like this. And I2 flows through this 20 ohm, 0.5 Henry and again this 100 volt. Okay, you should be clear with this. Then only you can write the KVL. Right. So now we are going to apply KVL for our loop 1 and loop 2. So when you look carefully, you see I1 flows through this 20 ohm as well as I2 also flows through this 20 ohm. So the voltage drop across this 20 ohm is written as I1 plus I2 into 20 ohm because they both flow in the same direction, okay, in the same path, in the same way. So 20 into I1 plus I2. And here I1 only flows through this 15 ohm, therefore 15 into I1 is equal to 100, right? So once you simplify, this is our final expression. Okay, name it as equation number 1. Now we have to apply KVL for our bigger loop, right? So again when you apply KVL, what happens? The voltage drop across this 20 ohm is 20 into I1 plus I2 plus here it is 0.5 into di2 by dt, right, which is equal to 100 volt here. So just write down the expression. Again we have to simplify. So once you simplify this, here we are getting the expression as 20 I1 plus 20 I2 plus 0.5 into di2 by dt equal to 100. Name this as equation number 2. Right. So now the thing is, you see, from this equation number 1, I am writing an expression for I1. Right. Because you see in the expression 2, okay, we are having I2. Right, I2 is maximum. So I am going to replace this I1 by I2 so that it is easy for me to calculate I2. Right. So the thing is, I am modifying this equation number 1. Just I am rewriting. So here this is your equation number 1 and I want expression in terms of I1. So here this is your expression. Right. So name this as equation number 3. Right. Now substitute this 3 in your 2. Right. So when you substitute, what happens? You see in the place of I1, I am substituting these values. Right. So after substituting, the next step is I am multiplying this expression with this 20. right? So just multiply and again we are simplifying. Okay, I am combining these I2 terms together. So finally, I am ending up with an expression like this, right? 17.14 I2 plus di2 by dt is equal to 85.72, right? So the next step is we are going to take Laplace transformation. So once you take Laplace transformation for this expression, you see di2 by dt becomes s into I2 of s. So the next step is I am taking I2 of s outside. Then finally the expression for I2 of s is 85.72 divided by s into s plus 17.14. Right. So again, in the denominator we are having two terms. So by partial fraction, I am splitting this expression into 2. Right. So just take LCM. After taking LCM, you see we have to find the values of A and B. So to find the value of A, I am substituting the value of S as 0. Therefore, the value of A is 5. And for the next thing, to find the value of B, I am substituting the value of S as minus 17.14. Right. Once you substitute minus 17.14, minus 17.14 and plus 17.14 cancels each other. Therefore, we can find the value of B easily. Therefore, the value of B is minus 5. So, the value of B is minus 5. Now, just substitute the values of A and B in the expression. So, this is your expression, right? Now, we need I2 of t. Therefore, we have to take inverse Laplace transformation. So, once you take inverse Laplace transform, the value of I2 of t is 5 by s becomes 5. And this 5 remains here as such, and s plus a becomes e to the power minus 80. So, this is your I2 of t. The next thing is we have to find the value of I1, right? So, again, consider the equation number 3. That is, consider this expression, okay? This equation. So, here I1 is equal to 2.857 minus 0.571 I2. So, take this equation, right? We know the value of I2. So, just substitute it over here. Again, multiply this 0.571 with the terms inside, right? So, once you multiply and simplify, the value of I1 is calculated as 0.002 plus 2.85 into e to the power minus 17.140 amps, right? So, finally, here we have calculated the values of I1 and I2. So, the important thing to be noted here is this is one form of solving the problem, right? So, initially what we have done is we will frame the expressions, that is KVL. We will apply KVL for the loops, okay? We will have equation 1 and 2. Then the next step is, then the immediate step will be, we will be apply Laplace transformation, right? By Laplace transformation, we will be proceeding and we will go with partial fractions. Then again, we will apply inverse Laplace transformation. Even you can use that method to solve this problem, right? This is just like maths, right? Anyway, you will get the answer. So, the method may be different, okay? Either you can use directly Laplace transformation and then you can solve. But here what we have done actually, we have substituted one equation in another equation, right? That is the main difference which is done here. So in either way you can solve the circuits. There is no compulsion that you should always use this particular method. So this is another way of solving the problem. Okay, take your own method. You can solve the circuits easily. Okay, take the comfortable method. Okay. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.